Well, hi, good morning. Thank you for joining me here in my shop on August 17th. So the performance of this radio really hasn't not gone skyward at all. It's still pretty weak. Maybe a little bit better for the work I've done so far, but not much. So there's still 1, 2, 3, 4 wax capacitors in here. So I'm going to pick on 2 to change. And the 2 I'm going to pick on, I've already been studying this. And, I normally don't do that. I normally don't come in my shop and start looking at stuff. I normally just come in, turn on the cameras, and away I go. But today I thought I'd spend a little bit of time studying things, and basically I've ended up with a level of confusion about stuff. When I'm comparing what I'm seeing in here to the schematic, it's not adding up. So let's go over what I'm doing. So first of all, these 2 capacitors are tied to a ground terminal right here. This terminal's on a short terminal strip, just has 2 terminals on it, and one of them is connected to the rivet that's riveted to the chassis. That's this one. That's got these 2 capacitors connected to it. So that's a little unusual. Capacitors connected to the chassis, not to B minus, but to the chassis. So it should be pretty easy to find these guys on the schematic. Let's just take a look a little further. One of them comes over here and connects to this terminal. This is terminal number, let me count it again. Make sure I get it right. That's 1, 2, 3, 4. That's terminal number 5 on the 12SA7. Terminal number 5 on the 12SA7. If we look in here, we count 1, 2, 3, 4, 5. We see it's grid number 1. Sorry about the focus there. Grid number 1. So this is a mixer tube. Grid number 1 often is associated with a local oscillator in a tube like this, though not necessarily. Grid number 1 has a fairly large capacitor going to ground, going to the chassis. Let's take a look at grid number 1 on the schematic here. Grid number 1. Looking at this tube, and so they have not numbered them here, but these are in their correct order. So I happen to know that the oh, look what they've done here. They actually are showing right in here where they've darkened in this portion. That's where the key is, on the center of the tube. See, they've done the same thing here. How subtle is that? And the same thing over here. Gee, I never noticed that till just now. Okay, well, that just verifies. Pin number 1 is supposed to go straight to ground, because that's the outer can, and we count 5. 1, 2, 3, 4, 5, and we get to a different pin from the one that I was considering earlier. Did I count the wrong tube? Maybe I must have. I knew I was making some kind of mistake. So we come down here. Wait a minute, whoa, there's no big capacitor here. So this is grid 0. G. So they're calling this a G oscillator because it's coming out of these oscillator coils. They're calling this the G. They're not getting a G1, G2. We have a grid here, but in the radio there appears to be a fairly large wax capacitor connected from here to the chassis. That doesn't make any sense. To me it doesn't make any sense. There's no large capacitors in this area of the radio except for that one. And it's not part of the picture. Oh my gosh, what am I seeing? What is going wrong here? There are no large capacitors. Well, let's just check. Can you find a large capacitor connected on any one of these lines? No. Especially from here to the chassis with a 0.05. Okay, we gotta look at the radio again because something's going wrong here. Something big is going wrong. I got the tubes mixed up. 12S8. Okay, let's look. If I'm dumb enough to get the tubes all mixed up. There they are. 12SK7. I do have them mixed up. Okay. No, wait a minute now. Yes, I do. I have them mixed up, for crying out loud. Okay, that answers that question. Thank you very much for helping me sort that out. Now, 12SK7, 12SK's down here. Okay, so we have pin number 1, which is the shield, the metal can shield, and then 5, 1, 2, 3, 4, 5 is the, okay, is the cathode on the 12SK7. Let's see what we can say about that. 12SK7. Okay, now 1, 2, 3, 4. Here's 5. There it is, right there. Now, so this is basically connected between the cathode and not really the plate, but the other side of this guy here. Well, I don't know. Maybe that's an important capacitor. I mean, they're all important. Maybe this one is responsible for the weakness in the radio. I'm not sure how to interpret it. Okay, just went away to look in a book for a minute, but nevertheless, I discovered just by looking at the schematic here, oh look, this line here goes right up to the B minus line. So this is a B minus connection. It's nothing to do with these tube pins. It's just a way to find ground. And what's it doing? It's putting a signal ground on the far side of this transformer. That's a pretty normal, everyday thing to do. So if you don't do that, then the signal's going to end up trying to find ground down through the power supply, and who knows what's going to happen. It's not going to work out. So yes, this one, if it's failing to do its job, I think it would weaken the output continuing along through the radio here. Okay, let's go after that one, and now the other one. Let's go after this one first, because it looks quite significant to me. No. The confusion's not gone away. So here it is on the pin 5 connection, but it's going to the chassis ground here. You know what? I've installed. Oh, this is strange. I've installed a capacitor underneath here. Oh no, it comes around to this other terminal. I'm putting confusion on top of the confusion. I guess maybe that's a rule. A little bit of confusion leads to more and more and more. It kind of has a self-multiplying effect. So what's going on here? What is going on here? In the schematic, there's only one capacitor connected to the chassis. It's got to be this guy. This guy here, the other end of it, attaches to this pin. This is pin number 1 on this tube, so it's the metal shield. And then there's a wire leading over to this tube, pin number 1, metal shield, and another wire leading off this way. You're going to lose sight of it. It comes all the way over to here. This tube, pin 1, you can see there's a resistor attached to it. What is that? So that resistor is 4.7 megohms. And I don't know where it is on the schematic. So connecting here is connecting to the other side of a capacitor. It's connecting through to the chassis. Connecting through a capacitor to the chassis. Which is what you want to do to pin 1. What's that resistor doing there? How does that factor in? Okay, back to the schematic. So looking at the other capacitor. So here it is here. This is the one I was just talking about. See, it goes right to ground. Quickly, let your eye run around Can you find another one of these symbols? Yeah, there's one over here. Shield straight to the ground. I'm having trouble finding this, by the way. Shield straight to the ground. This would be where the wire's coming. It's as if in this radio, rather than make this connection, they brought a wire from here all the way over to here. So then they've got all three of these tube metal cans grounded via this capacitor. But then there's a resistor thrown in. But there's no resistor in this circuit. And we don't know. This is something new. Since it's something new they did, for reasons we don't know. It's not on this schematic. Now, there is another version of the schematic, but it looked identical to this at a glance. But maybe it's not. Okay, so that's not a dramatic change. It just means rather than a direct connection here, they're running it through a capacitor. And they're connecting all the shielded cans together. So I think if this capacitor were weak, you would start getting weird oscillations and things like that. I don't think it would weaken the output. This guy has the potential to weaken the output. So we'll do this guy and see what happens amidst all this confusion. You know, it's one of the things humans are really, really good at. That's making decisions in environments where information is in conflict or insufficient. And you have to make a decision. Humans are very good at making the right decision. Not always, but okay. Maybe not in this case. Let's go do that capacitor. And I forgot to mention too, I'm a human. And lucky me. Very lucky. If you're a human, you're really lucky. You could have been a spider. You know, or maybe a cat. Well, maybe a cat wouldn't be so bad, but being a human, man, jackpot. So we're going to go after this guy here. Now there's a reason, it's reasonable to think there's a really good chance that what's inside our skulls is the most complicated thing in the universe. It's the pinnacle. We are the pinnacle of what the universe has done. It's possible. It's not an unrealistic thought. You know, we should be so thankful just for being. This is 0.025. But on the schematic it's a 0.02, wasn't it? Not that that's very different. Okay, why don't we test this guy right away? Here we go. So, job of this capacitor. Providing a ground at the bottom of the IF transformer primary. A signal ground. What if it's leaking? I don't know what to think of that. Here we go. Okay, watching the eye. She's a dud. Even on 50 volts the eye closes and doesn't open at all. So this is a very leaky capacitor. Oops. Yank on the cord there. Okay, so I'm going to put a replacement in. Maybe a 0.03 because I think I have a lot of those. I'll put a 0.03 in there. And away we go. Okay. Okay, got that little yellow capacitor in there. Good. Let's just turn this right side up. Switch is on. Ooh, it's the coffee time. Something's gone on right in here. Like it's been chewed or something. Seems okay though. Maybe the past owner got nervous and started chewing the power cord. Okay, looking at the dim lights. Volume is just up a little bit. Did I miss coffee break? Is that what just happened? Here we go. Okay, all is normal. Okay, we're going to give it the full treatment here. No, we're not. I made a little mistake there. So what I've done is I've elevated the input voltage here, and then the voltage is dropping on these lights, even though you can't see that the lights are actually doing that because they're not glowing, but they're dropping voltage. In the end, they get 113. But when I flipped my switch there and took the power directly from here, it's 124 volts. That's a little much for this guy. Okay, so lots of volume. We're sitting right on a noise signal. Here's the station that we're getting all the time with this radio. I'd say it's better. I'd say that's better. Let's go and check some more. See if we can get some more stations. There's one there. Didn't I get that French station here last time? I discovered the antenna direction was really critical. Not coming in. Not going to happen. Okay, well, it's pretty obvious that this, changing that capacitor was not a miracle for this radio. It's still not performing terribly well. A lot of radios don't perform all that well here in my shop. Oh, that's saying, well, that's something you just admitted to, Jim. Shame. Because of conditions here in the shop, and I guess I'm the condition. Yeah. Well, that's okay. I think we got lots of time here. I think I'll do the other capacitor, the one that's right next to it, just to get that out of the way, and then that'll be the job for today. Okay. So the one I'm talking about now is the one that's being used to achieve the metal can grounding on all of that's this guy here. Okay, well, we can cut them out and we can do a test on them. Okay, unplugged, yeah. Okay, we'll cut them this way. Pull that guy out of there. Pretty short. This one is a yeah, I think I just ruined it. Well, it's supposed to be a .02, wasn't it? I will check. Let's put it on the machine here. Looks a little large. I think it's a .05. And while that's warming up, I'm just going to peek at the schematic here. .05. 0.05 is what it is. Okay, Mr. .05, what do you say? You say I am shot. He's shot. At least it's leaking. In this position, what would a leaky capacitor do? Well, often, you know what, they, in a position like this, they often parallel these capacitors with a large resistor, like a 500,000 ohm resistor or something like that. 100,000 ohm resistor sometimes. So maybe it doesn't really have any functional, doesn't cause any kind of functional degradation. So I'll put the other capacitor in, the new one in, and we'll go from there. Okay, got that capacitor installed there. Good. Let's see what's happened. Don't expect anything has happened. That's probably why something good has probably happened. Because I'm not expecting it. Okay, here we go. Seem better? That's probably 680. 680 should be up here though. It's a station there. Some weird stuff. I don't think we're going to get the French station. It might have been here. Okay, let's just check something interesting. So this guy picks up some sparky interference. Right there. And that's got to be around 650 in fact. What does this radio pick up? 650. $630. $630. $730.
Got the sparky stuff in. I don't really hear it on this radio. Just lots of noise. Lots and lots of noise. Well, maybe I just didn't tune it right in on that other radio, but strange. Okay. So, as I think I mentioned before, when I did the alignment stuff for this radio, I just did the IF, and I just did it. I just winged it using my ears. There could still be, if the alignment were done properly, maybe this radio would perform a lot better. So it could be, it's nothing to do with the capacitors. There's only 2 left in there to do, and that's for the next time. And then after that, we'll have to do the more thorough alignment and see if that'll get it catching the French station and other stuff. So thanks a lot for watching, and I'll see you on the next video. Have a good day.